Now let's talk about how to do this on Excel. For Excel, there are nice functions that Excel has pre-written out for us so that we don't have to actually look it up on a table. For normal distributions, when you know the mean and the standard deviation, there's ways to go from the raw score to the area underneath the curve. So basically, it's very similar to that picture we saw on that z-score. What it'll give you is this cumulative probability, so the entire area below that value. And so the normal distribution, you need to enter in the mean and the standard deviation. So in order to go from the score into the probability, you would use the norm dist function. And you would put in the score, but you'd also put in the mean, the standard deviation, and there's another thing. You also have to put in true in order to get the cumulative probability, because this is sort of asking cumulative probability, and you're like, true, yes. And that will give you the probability at that score, the cumulative probability at that score. Norm inverse is just the inverse of that. So here, you give it the probability, and it spits back out the score. So here, you give it the probability, the mean and the standard deviation, and it spits back out to you the score. So notice that these two are inverses. That's why one of them is called norm inv. Because in one, you get the probability, and the other, you get the score, right? So these are our two flipping around values. For standard normal distributions, you don't need to enter in the mean and standard deviation because all standard normal distribution means are 0 and the standard deviation is 1. The mean is 0 and the standard deviation is 1. And so it makes it a lot simpler for us. The only difference between normal distribution and standard normal distribution is this one little letter. All you have to do is remember to enter in norm S dist. And here you could just put in the score, forget everything else, and it'll spit out the probability. For norms inv, it's exactly the opposite, where you put in the probability and it'll spit back out the score. And I should say z-score here. Now, another handy little function might be the function standardize. Here, you put in the raw score, the mean, and the standard deviation, and it will give you the z-score. This standardized formula simply uses this standardized function simply uses the formula that we talked about earlier, where in order to give you z-score, it takes the raw score, or x, minus mu, divided by standard deviation. All right, so given that, let's look at a few examples and do them in Excel. The distribution of SAT scores for math for incoming students to the university was approximately normal. So that's, again, important. It has to say approximately normal. Watch out for that. I don't know if you guys have tricky instructors or tests, but sometimes they might give you a problem that looks like a normal distribution problem, but it doesn't say it's normally distributed. With a mu of 550 and a standard deviation of 100, what percentage of scores were 400 or below? Now note that 400, if you transformed it into a z-score, wouldn't be a nice even z-score like -1 or -2. It's actually like -1.5, right? So that's going to be a little bit difficult for us to use just the empirical rule. That's why we're going to have to use something like either the table in the back of your book or Excel. So here I just have an empty Excel sheet. And one thing that I'm going to do is I'm just going to use my columns to denote probability, raw score, z-score, just because that's going to help me keep track, like, okay, what am I doing, right? And I'm also going to write down my mean and standard deviation just to help make things a little easier. 550, 100. And I need probability. And I need my probability where x is less than 400. So that's what I'm going for. My raw score is 400. And my z-score, what is my z-score? Now, I can just do this in my head, and so can you. It's just the distance, 150 divided by 100. So, and it's on the negative side, so it's negative 1.5. But just to practice using Excel, let's use our standardized function. So standardize. And Excel will guide you into what exactly you need. You need your x value, the raw score, the mean, and the standard deviation. And so I'm going to close my parentheses, and I get negative 1.5. The other way you could do this in Excel is actually do the formula, because you know that you need the raw score minus the mean, and all of that divided by the standard deviation. And I get the same thing, but I just wanted to illustrate for you that's what the standardized function is doing. Once you have that, now you need the probability. I could find the probability in two ways. One, I could use the standardized, the standard normal distribution, or I could use the regular normal distribution. Let's do both. So first, I know that it's the norm dist. I don't need the inverse one because I have the raw score. I need the probability. So let's start with norm dist. And here I know I need my x value. And I know I need the mean and the standard deviation. And it's going to ask you cumulative. And you just write true. And it gives us 0.0668. And that sort of makes sense. If we think about where negative 1.5 is, it's between negative 2 and negative 1, right? If it was at negative 1, it would be like 16%. If it was all the way at negative 2, it would only be like 2%. So 6% sounds about right. It's in between 2% and 16%. We could also do this by using norms dist. So norms with the S, dist. And for that, all you need is the z-score. So I'm going to put in my z-score. And I should get the exact same thing. Because remember, the z-score corresponds with the raw score, right? And they're right above each other. So the probabilities at that point should be exactly the same. All right. All right, now let's talk about the different types of problems. Now that you know z-score and standardized normal distributions, what kinds of problems might come your way? Well, now the full set of information, you don't always need all of these numbers, but the full set of information is the mean, the standard deviation, the probability, the raw score, or x, and the z-score, or I'll just usually write it as z just to make it simpler. So that's the full set. Any one of these things can be missing, and you could find it, right? So what's missing here? Here we have that same prompt. It says, what percentage of scores were 400 or below? So that's percentage of scores. Or it might ask, what percentage of scores fall below the z-score, negative 1.5, right? My negative sign didn't go over. So here we see that they're both about percentage of scores. So what might be missing is this. If you have either one of these and these two, you could find it, no problem. Here's another set of problems. Same prompt, but what's missing here? Here it says what math score separates the lowest 10% from the rest, or what z-score separates the lowest 25% from the rest. Here you have the probabilities and you have the mean and standard deviation, but one of these two things might be missing. So I think of these as the score missing problems. So we have probability missing problems and we have score missing problems. Now the last set looks like this. Note that this prompt does not give you the standard deviation, but it does give you the z-score and the raw score so that you could find the standard deviation here, or it gives you the percentage and the raw score, and then you find standard deviation, right? So here, something like the standard deviation is missing. You could also find the mean to be missing as well, and they would look very similar to these problems. As long as you have some combination of the other variables in place, the other values in place, you could actually figure out what's missing. So now let's edit our shape analogy that we did in the previous lesson. I'm going to skip over a lot of this because it all stays the same. The only part I want to draw your attention to is right here. Before, we could only look at probabilities and raw scores, but now we have expanded our repertoire. We could look at probabilities to raw scores to z-scores and even find the missing mean and standard deviation. And that is all done through a combination of the z-score formula as well as either the tables or Excel.